Welcome to the first video of Unit 4, Systems of Equations. Today we are going to talk about how to solve systems of equations by graphing. If I were to just draw any two random lines on a paper, I have three options of what could happen. First of all, these two lines might just intersect in one place. They might cross in one point. My other option might be that my two lines don't intersect at all. Maybe they're parallel. Or I could draw one line and have the second line be right on top of it. That could be my third option. So let's apply this now to solving systems of equations. If I were to actually draw some lines on a coordinate system with an x and a y axis, I could draw, again, two lines that intersect, and they could cross in one place, and we call that having one solution, because the solution is the point where the two lines cross. And this particular system of equations has one point right there where these two lines cross, so it has one solution. Okay, so if I drew another set of axes, and this time I had the two lines that don't ever intersect, maybe they're parallel, they will never intersect, and so these two lines have no solution. There is no point where those two lines cross, so they don't have a solution at all. And then what would happen in our third scenario? Of course, if I had my coordinate system and I drew one line and then I drew another line and it happened to lie right on top of it, how many times do those two lines intersect? Well, they intersect right here and right here and right here and right here, all these places. In fact, they intersect an infinite number of times. And so if it ends up being the same line, it will have an infinite number of solutions. So those are the three scenarios that you can have. You could either have one solution, no solutions if the lines are parallel, or an infinite number of solutions if they end up being the exact same line. Let's review how to graph linear equations just for a minute. We have been talking about these all year, actually, but you might not have realized that what we were talking about were linear equations. When we did arithmetic sequences, they were actually linear equations. So let's just review a little bit from last year even. When we have a basic line, the number being multiplied by the x is what we called the slope. When we talked about linear equations, we talked about that being the pattern. And when we talked about arithmetic sequences, that was our difference, the thing that we were doing every time, the thing we were adding every time. That is our slope or the pattern or the common difference. Okay, so then our number that is not being multiplied by x, the constant, we called that the y-intercept. But when we did arithmetic sequences, that was our starting point. Or we also called it the zero term. That's an A. So it's our starting point or our zero term. So you have seen these equations for quite a few weeks now in 9th grade. Well, let's review how to graph it. If we have an axis, a coordinate system with an x-axis and a y-axis, let's say that I give you the equation y equals 2/3 x minus 1. We're going to graph it on this system. Well, our y-intercept is the starting place. That's what we want to look at first. And that for us on this equation is -1. So we're going to go to -1 on our coordinate system, and we'll put a dot. That represents our starting point. Now our pattern, what were we doing every time? We were going up 2/3 every time, or our slope is 2/3. And remember that we talked about last year the slope being rise over run. So for this particular slope, we're going to rise 2 and run 3. So from our starting point, we're going to rise 2 and then run 3, and that puts us right there. We can connect those two dots, and there's our line. So that's just a quick review. I'll do a couple more. What if we have, for example, y equals negative 4x plus 2? We really like it when our slope is a fraction because we've talked about it as being rise over run, but this particular slope is not a fraction. Well, you can turn any number into a fraction by dividing it by 1. So that tells us that the slope for this line is negative 4 over 1. We're going to rise negative 4 or go down 4 and then go over 1. So let's graph this line. We're going to start at 2. 2 is our starting place. That's our y-intercept, so it's on the y-axis at 2. And from there, we are going to go down 4. 1, 2, 3, 4, and over 1. And that is our next point. Every time our pattern is going down 4. So if we wanted to go over 2, we would go down another 4. 1, 2, 3, 4. And that would put us way down here. You can see that those points are all on the same line. So that's just a quick review of graphing a line when it's in sloped intercept form, which is y equals mx plus b. What happens, though, if your line is not in slope intercept form? Maybe it's given to you as 3y equals x minus 9. How do you graph that? It's not in slope-intercept form because there is a number, this 3 here, in front of the y. So we need to fix it. And what we're going to do is solve for y, and to get the y by itself, it's being multiplied by the 3, so we're going to divide each side by 3. And I'm going to divide this x by 3 and the negative 9 by 3. On the left-hand side, 3 divided by 3 is 1, and 1 times y is just y. So we did it. We got rid of the 3 over there. But what's happening over here on the right-hand side? X divided by 3, another way we could think of that is 1x divided by 3, and I'm going to go ahead and write that instead as 1/3 times x, because that way it gives us a slope and to use just rise over run, a fraction, and x divided by 3, dividing by 3 is the same as multiplying by 1/3, so that's why I'm allowed to do that. Now, 9 divided by 3 is 3, and so that gives me an equation that I can graph. Y equals 1/3 x minus 3. You would go to negative 3 on your y-axis, and from there go up 1 and over 3 to do your line. All right. What does it mean to solve by graphing? Well, we are going to graph the lines that we are given for the system and then tell the point where they cross. So this problem says give the solution for the system y equals 4x minus 1 and y equals 2x plus 5. I'm going to graph the first line here in purple. I'm going to go to negative 1, that's my starting point, put a dot. And from there, my slope is 4, but I'm going to rewrite that as 4 over 1, so I have it in rise over run. And from my starting point, I'm going to rise 4, 1, 2, 3, 4, and run 1. That puts me right there. So this first line is pretty steep. It's going to go through both of those points. Now the second line I'm going to graph in pink. It's also already in slope-intercept form, but my slope is not a fraction, so I'm going to go ahead and turn that into 2 over 1 so I can have it in the form rise over run. And I'm going to start at my starting point, which is 5. 1, 2, 3, 4, 5. Here is my starting point. That is where my line intercepts the y-axis. And from there, my slope is to rise 2, 1, 2, and run 1. So you can see that my slope of this line is not quite as steep, but it will eventually intersect this other one. Oh, let's imagine that's a straight line. Okay, now the problem said to give the solution. Those were our instructions. And you can probably already see one weakness to solving a system of equations by graphing. It's quite hard to tell where these two lines intersect. In fact, I'm going to have to extend my purple line up a little bit, and then I'm pretty much just going to have to estimate what are the coordinates of that point right there. Well, it looks like I went over maybe somewhere between 2 and 3. And let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't know, it looks like maybe if my lines were straight and everything, I would guess maybe that's at the point 2, 9. It's actually 2.5, 9. We could even give it a better estimate by saying I think it's crossing at about over 2.5 and up 9. Now, we know that this is just an estimate, and if I used algebra and something that you're going to use in the future to solve this system, I actually found out that the proper point of intersection for these two lines is at 3:11. So you can see my lines aren't perfectly straight. My gaps aren't exactly even on my axis, and this really was just an estimate. And that's all I'm asking you to do. When you are asked to solve the system by graphing, I just want you to estimate. Do the best you can, make the lines as straight as you can, and get as close as you can. Okay, here's another one to solve. Let's solve this system by graphing. We're going to start off by looking at both of our lines. They're already in y-intercept form, so that's good news. We don't have to do any algebra to solve for y. And I'm going to graph the first line again in purple, and it starts at -6. 1, 2, 3, 4, 5, 6. So I'm going to put my y-intercept at -6, and now my slope is 4/5. So from there I'm going to rise 4 and run 5. 1, 2, 3, 4, that puts me right there, and there's my line. Now I noticed something interesting about my second line. It happens to have the same slope. What do I think is going to happen if I try to graph a line that has the same slope? Well, let's see. Now I also noticed something else. This second line has no y-intercept. Well, if it helps you to understand, that's like adding 0. In other words, we're starting at 0. So my y-intercept is right here at the origin at 0, 0. And from there, I went up 4, and I went over 5. And when I graph these two lines, you can see that they are parallel. They will never intersect. And so to solve this by graphing, I need to just say, hey, there's no solution, because they don't ever intersect. There is no point where these two lines cross. And here's a big hint. If they have the same slope, they will never intersect, because those two lines are parallel. So if you can look at two lines and notice that they have the same slope and different y-intercepts, right here, then you can safely say they're not going to have a solution. Last one we're going to talk about today is a problem that is given to us when the lines are both not in slope-intercept form. So I'm going to take this line right here, and I'm going to do some algebra on it, fix it so it's in slope-intercept form. Right now it says 3 times y, and I need y to be by itself. So I'm going to undo multiplication by division, and I'm going to divide both sides of this equation by 3. 3 divided by 3, I'm going to divide the 6 by 3 and the -12 by 3. You could have drawn just one line and divided the whole right-hand side of the equation by 3, but because we want this to be in the form y equals mx plus b, we're going to go ahead and divide those separately. So 3 divided by 3 is 1. 1 times y is y. Y equals, well, 6 divided by 3 is 2x. And -12 divided by 3 is -4. So the two lines wait a minute, these are the same. Look at that. If I were to graph both of these lines, they would be exactly the same. They would start at -4, and they would have a slope of 2/1. And so I would graph the first one, but after I did the algebra, I realized that these are actually the very same line. I couldn't graph the equation when it was in this form, and by doing the algebra on it, I realized they have the same slope and the same y-intercept. What does that mean for our problem where it asked us to solve this by graphing? Well, how many times do these two lines intersect? An infinite number of times. So this system has an infinite number of solutions because these two lines lie right on top of each other. They touch in an infinite number of times.